Okay, today we shall be developing a growth model that you can see from here. Growth model that we shall develop today. And here our model is 1.1. That is our model. So actually, this is our model, growth model, right? And here, what is y? Y is the y is the cells volume. But what I have done, I have converted the variable into log y. You can see. So the variable has been converted to log, right? So the variable has been converted to log y, and c1 is the constant, and t is the time period. So here t means 2007 to 2010, and E is the residual. So that is our model 1.1. Okay, and here and the equation 1.1 actually a semi-log model. So actually 1.1, the model actually is a semi-log model as why only one variable is in the log form. So here only one variable, that is the dependent variable, is in the log form, in the log shape. So this type of model we call it semi-log model. Semi-log. You can see from here. That means only one variable is in the log form. So semi-log model. So actually this one is called semi-log growth model. And what is our question? The question is that what is the sales growth rate over time? That is the question, and that we want to estimate. What is the sales growth rate, which is y, right? Suppose sales of car. What is the uh, growth rate of sales of car? So that is the question. What is the sales growth rate over time? That we want to estimate. Okay, and we have that data to estimate the sales growth rate. Okay, then what I shall do, I shall be estimating the equation 1.1 and do the residual test, right? That we shall be doing. I shall be estimating the equation 1.1 and do the residual test, and our model, estimated model 1.1, should not have any serial correlations or autocorrelation. Residual should be free from heteroscedasticity, and the residual must be normally distributed. So this thing should be there in the model. And finally, in addition to this, residual of model 1.1 should be stationary. So that means in this model there should not be any serial correlation, should not be heteroscedasticity, and the residual should be normally distributed. At the same time, the residual of the model should be stationary, right? And for testing stationary, we shall be using correlogram. That we shall be using for testing the stationary of the residual. Correlogram, meaning that Q statistics. We shall be using here Q statistics or correlogram. And here, what is our null hypothesis? Residual is stationary. And what is alternative? Residual is not stationary, right? So that is our null, and that is our alternative hypothesis. And luckily, our estimation has passed all the tests above. That means there is no serial correlations. That means the residual is normally distributed, and there is no heteroscedasticity, and finally the residual is also stationary. So all tests have passed. So we can say that our estimated semi-log model 1.1 is valid, meaning that this model is all right for growth prediction. This model is all right or valid for growth estimation or growth prediction. Okay. So that is the story, and here is the terms of uses that you can see.